This is SpaceTime, Series 23, Episode 70. Coming up on SpaceTime, the Australian Space Agency to help NASA and ESA develop a new generation of spacesuit, discovery of a new type of subatomic particle, and a new generation of space toilet to go where no one's gone before. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The Australian Space Agency is working with both NASA and the European Space Agency on a new generation of spacesuits for astronauts. The agency is looking at developing 3 types of compression spacesuits, each designed to protect astronauts from the physical strains of space. 2 of the designs will be developed as advanced prototypes, while the third will be developed as a concept. Led by local company Human Aerospace together with RMIT as the primary university partner, the technology is designed to also be transferable for medical applications, including burns injuries, sports injuries, lymphodemas, osteoporosis, and even cerebral palsy. Astronauts have been known to grow up to 7 centimeters taller as their spines lengthen in weightlessness, and that can cause back pain during the mission and an increased risk of slipped discs once they're back in the 1G environment of Earth. And of course, human bodies in weightlessness, once unloaded of gravity, also weaken. Astronauts not only lose muscle, but also up to 2% of their bone mass for every month they're in microgravity. And with future missions to Mars expected to take up to 2 years with current technology, astronauts will end up suffering from an extreme version of osteoporosis, during which their hip bones could age by as much as 50 years during the mission. Dealing with long-duration spaceflight aboard the International Space Station means at least 2 hours of daily exercise. And while that's proven to be fairly effective aboard the space station, longer journeys to Mars simply won't have the room to carry bulky exercise machines or the spare parts needed to keep them operational. And that's why the new prototype spacesuits are being developed. The idea being it will allow astronauts to keep in shape simply by wearing it. It'll be a type of skin suit designed to mitigate bone and muscle loss as well as other health side effects from weightlessness by imposing Earth-like longitudinal loading on the torso and lower body. In short, it'll be a sort of skin-tight elastic suit specifically designed to mimic the impact of gravity on the human body. Being very light, elastic and requiring no external power means it will allow astronauts to continue working when in use, so it will be well suited for extended space missions. An earlier version of the skin suit's already flown twice on the International Space Station as part of a European Space Agency program, where it was assessed for its operational readiness and its ability to help reduce spinal elongation. It's specifically designed to be worn on extravehicular activities, or EVAs, that's NASA speak for spacewalks, and not just floating outside the capsule either. We're talking about walking on the lunar surface and eventually on Mars. Existing gas-pressurized suits for spacewalking are amazing personal spaceships. Trouble is they're also very bulky, very heavy, incredibly rigid, and they require a high degree of maintenance. And that's where the new elastic skin suit pressure layers come in. They could work well both as an alternative or as a supplement to traditional gas-pressurized layers in the spacesuits. Of course, the skin suit concept for spacewalks has been around since the 1960s. But the main challenge has always been how to activate the elastics so as to manage the pressure while still allowing the suit to be put on and removed easily. Once that's achieved, the skin suit could become a viable option, providing a lighter, safer and much more dexterous spacesuit. Meanwhile, the third spacesuit is being developed by the team more as an Earth suit than a spacesuit. See, in space, blood pressure equalizes all over the body. The movement of extra blood to areas where it's normally not needed is one of the reasons astronauts always feel like they've got a head cold when in orbit. But then, when astronauts return to Earth, blood is again affected by gravity, and it begins to pool in the lower extremities. Now, having become unused to this pooling, astronauts can faint from what's known as orthostatic intolerance. So the new prototype suit's designed to be worn by astronauts on their return to Earth to help reduce blood pooling, similar to the G-suits worn by fighter pilots, but without the need to grunt. And this is technology which won't only help astronauts, but it could also help the broader population with medical conditions like burns, lymphodemas, and peripheral vascular disease. You're listening to SpaceTime. Still to come, NASA is seeking expressions of interest in developing a new lunar loo for its Artemis astronauts exploring the moon. And in July, SkyWatch, Earth reaches aphelion, its most distant orbital position from the Sun, and we're treated to 2 meteor showers this month, the Delta Aquariids and the Alpha Capriconids. All that and more still to come on SpaceTime. Scientists have discovered a new never-before-seen subatomic particle. The exotic particle is made up of 4 charm quarks. A report on the pre-press physics website archive.org describes the detection of the new tetraquark as the first of a previously undiscovered class of particles. The discovery was made by physicists with the L8CB collaboration at CERN, the European Organisation for Nuclear Research. Quarks are elemental subatomic particles and a fundamental constituent of matter. They combine to form composite particles known as hadrons, the most stable of which are the protons and neutrons which often make up atomic nuclei. Due to a phenomenon known as color confinement, quarks are never directly observed or found in isolation, but are only seen within hadrons, which exist either as baryons, which are made up of 3 quarks such as protons and neutrons, or as mesons, which have 2 quarks. There are 6 known types of quarks, referred to as flavors: up and down, top and bottom, sometimes called beauty, charm and strange. The up and down quarks have the lowest masses and are the most stable. The up quark has a charge of 2/3 of an electron volt, while the down quark has a charge of minus 1/3 electron volts. The proton is composed of 2 up quarks and a down quark, while the neutron appears to be made up of 1 up quark and 2 down quarks. Now, the heavier quarks, that's the top and bottom and charm and strange, will rapidly change into up and down quarks through a process of particle decay. That's the transformation from a higher mass state to a lower mass state. Because of this, up and down quarks are the most common type in the universe, whereas strange, charm, bottom and top quarks can only be produced in high energy collisions, such as those involving cosmic rays or in particle accelerators. And for every flavor quark, there's also a corresponding antimatter counterpart or antiquark that differs only in that some of its properties have equal magnitude but opposite sign. As well as quarks, the nucleus is also made up of gluons, which mediate the strong nuclear force that binds the nucleus together. For decades, theorists have predicted the existence of 4 and 5 quark hadrons, which are sometimes referred to as tetraquarks and pentaquarks. And over recent years, laboratory experiments have confirmed the existence of several of these exotic hadrons. These particles, made of unusual combinations of quarks, provide an ideal laboratory for physicists studying the strong nuclear force. A detailed knowledge of the strong nuclear force is also essential for determining whether new unexpected processes are a sign of new physics or just an extension of the existing standard model. Now, as we mentioned before, particles made up of 4 quarks have already been found. But what makes this discovery different is that the 4 quarks involved are all of the same type, specifically 2 charm quarks and 2 charm antiquarks. The authors found the new tetraquark by sifting through the full LHCb datasets from both the first and second runs of the Large Hadron Collider. These took place between 2009 and 2013 and from 2015 to 2018. As they sifted through the reams upon reams of data, they noticed a slight bump in the mass distribution of a pair of particles consisting of a charm quark and a charm antiquark. And it wasn't an aberration against the background noise. This had statistical significance, more than 5 sigma in fact, that is 5 standard deviations, which is the threshold used for claiming the discovery of a new particle. And it just happens to correspond to a mass at which particles composed of 4 charm quarks are predicted to exist. Now, as with previous tetraquark discoveries, it's still not completely clear whether the new particle is a true tetraquark, that is, a system of 4 quarks tightly bound together, or if it's simply 2 quark particles weakly bound into a molecule-like structure. Either way, the new tetraquark particle will help theorists test models of quantum chromodynamics, the theory of the strong nuclear force. This is SpaceTime. Still to come, Earth reaches aphelion, its most distant orbital position from the Sun, and a new space toilet to go where no one's ever gone before. All that and more still to come on SpaceTime. NASA's calling for expressions of interest in developing a new lunar loo for its Artemis astronauts exploring the moon. space bathrooms come a long way. Back in the days of Apollo, astronauts wore diapers. And while the space shuttles were equipped with vacuum-powered space toilets, which were also fitted to the American side of the International Space Station, these cosmic crappers were incredibly bulky, with little more than a plastic seat and a tight seal, a hose with lots of suction, and grips to hold on with as you, focused on the important business of the moment, I guess. They were also very difficult for females to use and were very sensitive when it came to crew alignment on the seat, which could result in messy situations if, shall we say, dunny docking wasn't performed correctly. And there are often plumbing problems with the apparatus compressing the waste, making matters worse, especially if time suddenly becomes an issue. NASA's new Universal Waste Management System, as they're calling it, will hopefully resolve these issues, bringing the lunar latrine up to the next level. I'm not sure if that level is number 1 or number 2, but hopefully both. Another problem is size. Crews exploring the moon will need a smaller, lighter, simpler toilet inside their lunar lander because every ounce of mass on the lander is carefully allocated. For every kilogram of mass, 10 kilograms of propellant will be needed to descend to the lunar surface and then launch back to the Gateway space station. So, the new Astro outhouse will need to be compact and low mass, reducing the current cosmic Kazi from 54 kilograms down to just 31, and decreasing its volume by 70%, from 0.17 cubic meters down to just 0.12 cubic meters. All this while still handling, shall we say, downloads up to 500 grams at a time. Word is the new Astro Dunny is likely to follow the design of the toilets on the Russian side of the International Space Station, which is a simple but effective design. And it's got some advantages. For example, astronauts simply hook their feet into tow bars rather than the thigh bars used on the American equivalent in order to anchor the astronaut in the microgravity environment. I guess that's proof that hundreds of years of heavy potato diets means the Russians know a thing or two about making a capable can. To find out more, Andrew Dunkley is speaking with astronomer Professor Fred Watson.
They're getting a new dunny. And for those who are going, what? A toilet. They're getting a toilet. This, I imagine, will be something that you could get at your local hardware store for about $100.
In your dreams, Andrew. What they're getting is something called the UWMS. Which is,
it sounds too scary.
It's the Universal Waste Management System, and it basically is a prototype for the kind of technology that will be needed for flights to, for example, Mars, where you've got really long missions in space, and where you've got to cope with what you generate in terms of human waste. And so what's happened is that the most inconvenient parts of the convenience on the space station at the moment, they are being designed out. And so the idea is to make the system as smooth and as streamlined and as easy to use and as foolproof as possible, which apparently the current one isn't. I think they're quite difficult to use, especially if you happen to be...
You don't really want to be in 0G and turn to someone and say, how do I use this thing again? What's this button for?
Yeah.
That would not be ideal.
It's a bit late by the time you get to that. So that the system that's used on the International Space Station is adequate, but could do with improvement. So what's happened is a new design has been evolved, which apparently is based more on its structure on the Russian design, because there's a separate Russian toilet and a separate American toilet. I'm sure they can use both, but they've got slightly different technology in the way that you support yourself on the seat. So it's following more of the Russian design. So this design has evolved, and with an eye on future waste disposal requirements for longer space flight. And what's happening is that a prototype is being sent to the International Space Station so it can be tried out in weightless conditions, because the last thing you want to do is build one, put it on a Mars flight, and then discover when you've just left Earth orbit that the thing doesn't work very well and you've got plumbing problems, which we're all familiar with.
You've got space doogies all over the place. That's the big danger.
I knew you'd get that into it somewhere. Never mind.
I had to.
Yeah, you had to.
I think I think the most disturbing part of this story is it's featured on the space.com website, and they actually quite literally have a video of you getting down into the bowels of a space toilet. I mean, it doesn't get much lower than that. It's perfect for us, but it doesn't get much lower than that.
Look, it's very basic stuff. It's all part of the human condition, and we're all gifted with this facility to produce waste, so you've got to deal with it. What surprised me was the estimate that this is a quote from one of the NASA officials who's involved with this. He's actually Deputy Program Manager for Environmental Control and Life Support Technology and Crew Health and Performance at the Johnson Space Center. He made the comment that current estimates suggest that Mars missions would need to manage about 270 kilograms of solid waste, about 75% of which is water. So it's a quarter of a ton more, actually, for a Mars mission. And that's probably just a one-way flight. You've got to do the same on the way back, I would guess.
Yeah.
It's not a trivial problem. And that's really why this is being done, to check out what new technologies you can involve yourself with.
It's also very handy if you get stuck on Mars and have to grow potatoes to survive until a rescue mission can be mounted. I've heard.
I've heard that too, but I'm not sure whether I believe it.
Feasible, but possibly not absolutely possible. Yeah. But all jokes aside, it is one of the big issues facing long-haul travel in space. What do you do with the waste? How do you process it? Where do you put it? How do you get it where it needs to go in the most convenient fashion without causing too many problems? And I was surprised that you said there were different toilets for the Russians and the other astronauts.
Just the design. I think it's the design of it. I don't think it's a segregated toilet. I think it's that the toilet on the Russian side of the space station, apparently it's about the way you support yourself. On the Russian side, the astronauts hook their feet into tow bars, whereas the American equivalent on the US side, you use thigh bars to anchor yourself in the weightless environment. Work that one out.
Does it require some sort of vacuum effect? Because otherwise, yeah. I think you could be running into trouble if you're relying on gravity.
There is indeed exactly that, a vacuum system. But the thing that always entertains me, there is a fan in there as well, or a device that actually fragments the bits and pieces, if I can put it that way, which, yes, it has echoes of a well-known phrase or saying, doesn't it, really?
Yes. Yes, and I think this show just hit the fan itself.
It did, yes.
That's Professor Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. And it's time now to turn our eyes to the skies and check out the celestial sphere for July on SkyWatch. July is the 7th month of the year in both the Julian and Gregorian calendars, and is named after the Roman Emperor Julius Caesar, who was born during the month. And yes, my bad, I know we got that wrong last month, sorry about that. Before being called July, the month was simply known as Quintilis, Latin for 5th. On average, it's the coldest month of the year in the southern hemisphere, which is experiencing winter, and also marks the time when Earth is at aphelion, its furthest orbital position from the Sun. Of course, temperatures, or more accurately seasons on Earth, aren't dictated by the distance from the Sun, but rather by the length of the day, and hence the amount of sunlight a given part of the Earth receives, which is all governed by the tilt of Earth's axis. Consequently, that's why July is on average the warmest month in the northern hemisphere, which is currently experiencing summer. During aphelion, Earth's roughly 152.1 million kilometres away from the Sun. That's about 5 million kilometres further away than where it is during perihelion, when it's about 147.1 million kilometres away. This year, aphelion occurred at 21:34 on the evening of the 4th of July, Australian Eastern Standard Time. That's 7:34 in the morning on July the 4th, US Eastern Daylight Time, Happy American Independence Day, and 11:34 in the morning on July the 4th, Greenwich Mean Time. Over cosmic time, these dates change due to variations in Earth's orbit, such as eccentricity, axial tilt, and precession, which follow regular cyclic patterns known as Milankovitch cycles. Eccentricity involves changes in how elliptical Earth's orbit around the Sun is. None of the planets orbit the Sun in perfect circular orbits, although Venus and Neptune are the closest. They all have elongated orbits, which vary slightly over time. And they all spin on their axes, which can tilt to varying degrees. In the case of the Earth, it's 23.4 degrees compared to the ecliptic, that's Earth's orbital plane around the Sun. But this angle of tilt also changes over time, influenced by, among other things, the distribution of mass around the Earth. And like a spinning top, the rotational axis of the Earth also changes its orientation through a process called precession, changing its position in relation to fixed background stars over a 26,000-year cycle. And all these effects impact the amount of solar radiation reaching the Earth, and consequently the planet's seasonal and climatic patterns. Okay, let's turn to the night skies for July. And the spectacular Southern Cross is at its highest point in the southern sky this time of year and pointing directly to the south celestial pole. The Southern Cross is located in the constellation Centaurus, the centaur, the half-human, half-horse of Greek mythology. The creature is holding a bow loaded with an arrow. The centaur's front leg is marked by the two pointer stars, Alpha and Beta Centaurus. At 4.3 light-years, Alpha Centauri, the second of the two pointer stars towards the Southern Cross, is also the nearest star system to the Sun. Centaur's back arches over the Southern Cross, and just above this is Omega Centauri, a spectacular globular cluster, visible even with the unaided eye from dark locations. Globular clusters are tight-packed spheres containing literally thousands to millions of stars, all originally born at the same time from the same molecular gas and dust cloud. Omega Centauri is about 16,000 light-years away. By the way, a light-year, well, that's the distance a photon travels in a year at 300,000 kilometres per second, which is the speed of light in a vacuum and the ultimate speed limit of the universe. Omega Centauri is one of the largest and brightest of the 150 or so globular clusters known to orbit around the Milky Way galaxy. Centaurus was included among the 48 constellations listed by the 2nd century astronomer Ptolemy, and it remains one of the 88 modern-day constellations. Okay, let's turn to the right now, or the west, and we see the constellation Leo the Lion, just above the western horizon. Its brightest star is Regulus, or the Little King, located about 89 light-years away. Regulus, or Alpha Leonis, is actually a 5-star system organized into 2 pairs. Regulus A is a spectroscopic binary comprising a spectral type B blue-white main sequence star some 4 times the mass and some 288 times the luminosity of our Sun. And there's a faint companion which is thought to be a white dwarf, the stellar corpse of a Sun-like star. Spectroscopic binaries are stars which are so close together they can't be resolved by optical telescopes into 2 separate objects, and can only be separated by observing their different spectroscopic Doppler shifts as they orbit around each other. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars in the universe are known as spectral type O blue stars. They're followed by spectral type B blue stars, then spectral type A white stars, spectral type F whitish yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive but also most common stars in the universe are spectral type M red stars. Each spectral classification can then further be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 being the coolest, and then you add a Roman numeral to represent luminosity. When you put all that together, our Sun is officially classified as a spectral type G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but then became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or if you prefer, 0.08 solar masses. Located further away from Regulus A are Regulus B, C and D, which are all regarded as dim main sequence stars. Main sequence simply means they're burning hydrogen into helium in their cores. The constellation Leo also includes many galaxies, including the spiral galaxy Messier 66, as well as Messier 65 and NGC 3628, which together are known as the Leo triplet. Located some 37 million light-years away, the Leo triplet has a somewhat distorted shape due to gravitational interactions between Messier 66 and the other two galaxies, which are cannibalizing stars from Messier 66. It's thought eventually the outermost stars will probably form a dwarf galaxy orbiting M66. If you've got a large pair of binoculars, you should be able to make out M65 and M66. A small backyard telescope would do the same job, of course. But if you want to check out their concentrated nuclei and their elongation, you'd really need a larger instrument. Other bright well-known galaxies in Leo include Messier 95, Messier 96, and Messier 105. Messier 95 and 96 are both spiral galaxies, each around 20 million light-years from Earth. Both will look like fuzzy objects in small telescopes, but will show off their spectacular structures in larger instruments. Messier 95 is a barred spiral. Another barred spiral galaxy, NGC 2903, is thought to be similar both in size and structure to our own Milky Way galaxy. It was discovered by William Herschel in 1784. Close to the M95-M96 pair is the elliptical galaxy M105, which is also around 20 million light-years from Earth. Above Leo is the spectacular Virgo constellation. Virgo was the Greek and Roman goddess of wheat and agriculture. The brightest star in Virgo is Spica, clearly visible above the western horizon. It's located around 250 light-years away. Spica is Latin for the ear of wheat, which Virgo is apparently holding in her hand. Spica, or Alpha Virginis, is the 16th brightest star in the night sky, and is both a spectroscopic binary and a rotating ellipsoidal variable, a close binary system whose stars are not eclipsing but cause an apparent fluctuation in brightness because of changes in the amount of light-emitting area visible to the observer. That's because Spica's two main stars orbit each other every 4 Earth days and are so close they are egg-shaped rather than spherical. They can only really be separated by their spectra. The primary star is a blue giant variable Beta Cepheid. It undergoes small, rapid variations in brightness because of pulsations in its surface, thought to be caused by the unusual properties of iron at temperatures of 200,000 degrees in the stellar interior. It has about 10 times the Sun's mass and about 7 times its diameter. The secondary star is somewhat smaller than the primary, but still some 7 times the mass of the Sun and around 3.6 times its diameter. Below Scorpius is the constellation Sagittarius, the archer which points the way to the centre of our galaxy, the Milky Way. Sagittarius is commonly represented by a winged centaur pulling back on a bow which is aimed at Antares. The centre of the Milky Way and its supermassive black hole Sagittarius A star lie in the westernmost part of Sagittarius. It's hidden by all the stars, gas and dust, but Sagittarius A star lies around 27,000 light-years away and has almost 4.3 million times the mass of our Sun. The brightest star we can see in Sagittarius is Epsilon Sagittarii, or Caus Australis, the southern part of the bow. It's a binary system located some 143 light-years away. The primary star is an evolved Spectral Type B blue giant at the end of its life on the main sequence. It is about 3.5 times the Sun's mass, almost 7 times its radius, and is radiating with around 363 times the Sun's luminosity. It's also a strong X-ray source, and it's spinning very rapidly, with an estimated radial velocity of some 236 kilometers per second. The system also displays an excess of infrared radiation emissions, suggesting the presence of a circumstellar disk of dust. The second star in the system appears to be inside this debris disk. Astronomers think it's a spectral type G yellow dwarf star with about 95% the mass of our Sun. Sigma Sagittarii, or Nunki, is the constellation's second brightest star. The name Nunki is Babylonian, however the meaning is unknown. It's thought to represent the ancient Babylonian sacred city of Urdu on the Euphrates River, and this would make Nunki the oldest known star name in use today. Nunki is a spectral type B blue star, located about 260 light-years from Earth. It has about 8 times the Sun's mass, about 4.5 times its radius, and around 3,300 times the Sun's luminosity. It was in July back in 2016 that the Solar System's Barry Center moved outside the Sun, a position it will retain until 2027. A Barry Center is the gravitational center of mass of a celestial system. For example, in, say, the Earth-Moon system, the Moon and Earth actually orbit around each other around a common centre of gravity, a barycenter. But because the Earth is so much more massive than the Moon, the barycenter is always inside the Earth's radius. In fact, were it outside the Earth's radius, the Earth and Moon would have been classified as a binary system, just like Pluto and Charon. Our solar system's centre of gravity, or barycenter, usually lies within the Sun's radius. After all, the Sun contains some 99% of the solar system's total mass. But once again, they're all actually orbiting around the solar system's barycenter, which means the Sun also has a very slight spiralling 12-year orbit around the barycenter. And every now and then, when the planets' orbital positions are aligned just right, especially when Jupiter and Saturn are nearest each other, their combined gravitational interactions moves the solar system's barycenter ever so slightly outside of the Sun's radius. And because Jupiter and Saturn reach this alignment every 11 years, some scientists have speculated this could be a trigger for the Sun's annual 11-year solar cycle. And before you ask, the barycenter isn't named after some guy in a beige safari suit called Barry, but rather it's an ancient Greek word meaning heavy or centre of mass. Come to think of it, I know a dude called Barry that matches that description. We also have 2 meteor showers, both of which peak in late July. The Delta Aquariids and the Alpha Capriconids. The Delta Aquariids can be further subdivided into 2 separate meteor showers. There's the southern Delta Aquariids, which are visible from mid-July through to mid-August each year, with peak activity on July the 28th and 29th. The shower originated from the breakup of what are now the Marsden and Crank sun-grazing comets, which originated from the parent comet 96P Markholtz. The Delta Aquariids get their name because their radiant, that is the position in the sky they appear to come from, lies in the constellation Aquarius, near one of the constellation's brightest stars, Delta Aquarii. Now, as I mentioned, there are 2 branches to the Delta Aquariids meteor shower, the southern and northern. The southern Delta Aquariids is considered the stronger of the 2, with an average of between 15 and 20 meteors an hour between midnight and dawn. Listeners in the southern hemisphere will usually get the best show because the radiant is higher in the southern sky. Now, since the radiant is above the southern horizon for northern hemisphere listeners, they'll see meteors fan out in all directions, east, north and west, but with few meteors heading southwards. That's unless they're really short and near the radiant. The northern Delta Aquariids are the weaker of the 2 showers, peaking later in mid-August, with an average peak rate of about 10 meteors an hour. Meanwhile, the nearby slow and bright Alpha Capriconids meteor shower takes place from roughly July the 15th through until August the 10th. This meteor shower has relatively infrequent but bright meteors and some fireballs. It's generated as the Earth passes through the debris trail left behind by the comet 169P Neat, which was originally identified as the asteroid 2002 EX12. However, it was shown to be weakly active during perihelion and was therefore reclassified as a comet. The meteor shower was created about 3,500 to 5,000 years ago when around half of the parent body disintegrated and fell into dust. The dust cloud evolved into Earth's orbit, causing a shower with peak rates of around 5 meteors an hour and some outbursts of bright flaring meteors radiating out of the constellation Capricorn towards the south. The bulk of this comet's debris won't be in Earth's path until the 24th century, by which time the Alpha Capriconids are expected to become a major annual meteor storm, stronger than any current meteor shower we experience. Joining us now is Jonathan Nally, the editor of Australian Sky and Telescope magazine, as we continue our tour of the July night skies on SkyWatch.
The constellation Scorpius, or some people call it Scorpio, but the real name is Scorpius. Also full of fantastic things. You've got globular star clusters, you've got open star clusters, you've got bright and dark nebulae, you've got all sorts of fantastic star patterns and things. It's really tremendous. Even a pair of binoculars will do a really good job of showing you what's up there. And if you've got a small telescope or you know someone who has, grab a hold of that as well. But look, even if you can get out to a dark sky and just use the unaided eye, it just looks really, really beautiful.
We really are lucky where we are, aren't we?
Yeah, well, we really are lucky. And that's sort of one of the reasons why a lot of major professional astronomy got started in the Southern Hemisphere, in Australia and over in South America as well, because some of the really interesting things that you can see, like the centre of the galaxy and the Magellanic Cloud galaxies, which are neighbouring galaxies, are best seen or only seen from southern latitudes. So that was one of the reasons why a lot of money was forthcoming originally to get things built up down here. But then, of course, long ago, astronomers moved beyond sort of what would now be classed, I suppose, as simple astronomy. And so they can look billions of light years out into deep space and sort of see things in every direction, whether it's north or south. But look, we are still very fortunate to have lots of great stuff to see, including down the south. You've got the Southern Cross, nice and high this time of the year, standing almost upright. Across to its left, you've got the two-pointer stars that sort of point the way to the Southern Cross. Over towards the right of the Southern Cross, moving towards to the right of it, also within the Milky Way, you've got lots of other great stuff to see as well, star clusters and nebulae and things. Get some binoculars onto that area. Up in the northern half of the sky, it seems pretty bare this time of year. It looks pretty empty of bright things. Bright stars. There are a couple of bright stars. You've got one of them called Spica, which is the brightest star in the constellation Virgo. And there's another one called Arcturus, which is the brightest star in the constellation of Boötes, which is not a constellation most people have heard of, I have to say. Have you ever heard of Boötes? It's spelled B-O-O-T-E-S. I think that's how you pronounce it.
The straw hats people wear when they go to private schools, isn't it?
Boaters, yes. Very good. Boötes, it means the herdsman or the ploughman. And so Arcturus is the brightest star. And that Arcturus is actually the fourth brightest star in the sky. The other one I mentioned, Spica, is the 16th brightest star in the night sky. And up there in the northern half of the sky, as seen from down here in the south, there's a very large constellation called Virgo, right? Very large star pattern, one that seems quite empty to the naked eye, but astronomers love Virgo, particularly amateur astronomers, because there are lots and lots of galaxies to be seen in there. You get a telescope onto that area and you can see the famous Virgo cluster of galaxies. There's galaxy after galaxy after galaxy. So it might look dull to the naked eye, but you get a telescope onto some of these areas and they do have lots and lots of really good little gems hidden amongst them. So turning to the planets, actually we're in for a real treat in July this month because the two largest planets of the solar system, Jupiter and Saturn, both reach opposition. Now, opposition is the point where a planet is in one direction in the sky as seen from the Earth and the Sun is directly in the opposite direction, 180 degrees that way. So the practical upshot of this is that as the Sun is going down in the west, when it sets in the west, the planet, being 180 degrees the other direction, will be rising in the east. So that means the Sun goes down, the planet comes up, you've got all night to see that planet, which isn't always the case. Sometimes a planet might rise, say, at midnight, and you've only got the hours between midnight and dawn if you want to get out, that time of night and do some observing. So it's really good when opposition comes around because the planet is easily accessible in the evening hours when a lot of people like to do their stargazing.
And for the longest amount of time. Yeah,
for the longest amount of time. And particularly, what happens if you go out at 7 o'clock and say, I want to go see Jupiter at 7 o'clock. I know it's up at the moment, but you go out and it's cloudy. Okay.
Exactly.
So you can't see it, but there's a chance that the clouds might move a couple of hours later, so you can go out at 9 o'clock and you might have it. So it's a good time to see planets. So at the moment, if you go out and any time this month, about 30 to 40 minutes after sunset and look to the east, you'll see Jupiter and Saturn coming up. Jupiter will be the really bright one, the one and it's above, and below it will be Saturn, not quite so bright. As for the other planets, well, we've got Mars also rising in the east, but at the moment it's rising just before midnight at the beginning of the month. And it just looks like an orangey-coloured mid-brightness sort of star. Venus is visible in the morning hours out to the east, so rising at about 4:30 in the morning at the beginning of July. And you can't miss Venus. I mean, it's brighter than all those other planets. It's very big and bright. Looks like the brightest star you've ever seen, basically. But it is the planet Venus. And the last one, Mercury. Well, it's also visible in the east before dawn, pretty low down towards the eastern horizon, though. And you'll only be able to see it in the last couple of weeks, roughly, of July. Prior to that, it's too close to the sun and gets lost in the solar glare.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your inbox or letterbox. And subscribing is easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.